Okay, let's start lab 6. Lab 6 consists of three main sections. In the first section, we manually apply some filters on images to understand how convolutional networks work. Then we will use a pre-trained network named ResNet to classify dot images based on their breeds or races. In the last part, we will use this pre-trained model to develop a customized model. In today's lab, instead of using terminal, we will use Jupyter notebooks. Jupyter notebooks has been installed on the server, so you don't need to install anything on your local machine. In today's lab, we use these Jupyter notebooks because it allows us to create graphical outputs. This week, we are going to work with images, and we will create some graphical outputs. So we will use Jupyter notebooks to create such graphical outputs. And now I want to show how you can connect to the Jupyter notebook installed on the cluster. Before connecting to the server, please ensure that you have connected to the university VPN, because we need to run the VPN before connecting to the cluster. So you can open the link we have here. So you can open the link, and then it will show you this login page. Now I enter my username and password. You should here enter your username and password you have already used to connect to the server previous. So once you click on this sign in button, you will be redirected to this Jupyter interface. So here you can see all the files and directories you have in your home directory. As I mentioned earlier, we will use this Jupyter notebook to write our Python script and run them. I split my screen into okay. Now I want to start writing Python commands or Python scripts. To do that, I click on this new button, and in the drop box, I can see some options. We want to write Python scripts, so I select Python 3. As we can see here, in the new notebook, I can see a cell. In this cell, I can write my scripts and then run this script using this run button here. Let's execute the first command. This is, as we can see here, an input and a Python script. So I copy this Python script and paste it here. This is a Python script showing a YouTube video. So as you can see here, I have copied and pasted the code to a cell. To run this command, I should press this run button here. So this is the output of this script. This is a video. As you can see here, I selected this command and then run it, and the output of this command is here. Before doing the first part of this lab, please watch the video, because we need some points of this video to do some modifications in the scripts and do some more filters on the input images. Now I want to apply a filter on a sample image. As I mentioned earlier, in the first part of this lab, we want to manually apply some filters on images, because in the lecture I explained that convolutional networks apply some filters on images to extract some features from images, and based on those features, the network infer the output. Now we want to do this filtering task manually. In this piece of code, after some initialization and imports, we load an image and show the image. They are all Python codes, but we use them, we run them in Jupyter notebooks. The data set is available on the cluster. So this is the path to the data set. So this is a path on the data set, and if you here, let me if I ls this path, you can see there are a huge number of images in this path, in this folder. So I want to load one of the images in this folder and then show the image. So I copy the image, the script, and paste it here. Now I have the code here. To run this code, I select this cell and run it. This is the image. We are going to do some filter on that. We want to apply some filter on that image. Now I have uploaded this image, and the image is stored in this. Anyway, we can say this is a tensor, but it is not a real tensor. But anyway, you can imagine this original image as a tensor. It's a matrix. Now I want to apply a filter. This is the filter I'm going to apply. This filter will be applied to each part of this image to extract horizontal lines or horizontal edges in this image. Okay. As you can see here, I copy the script and paste it here. This is the filter. As I explained in the lecture, filters are stored in matrices. And then in neural networks, we have matrix vector multiplications to find new representations of the input data. So here we have the weight matrix. As we can see here, we have created this weight matrix manually. But in real cases, in real neural networks, all these weight matrices are created by backpropagation algorithms and any other training algorithm. But here we created this matrix manually. Then using this method, apply convolution to image, we applied this convolutional filter on the original image. This is the original image. We have already uploaded it. Okay, we apply the filter. The output image is stored in another data structure named filtered image. And then this command displays the filtered image. Let's run this command. So now I select this cell and run it. As we can see here, this filter extract all horizontal lines or all horizontal edges in the image. As an exercise, please watch this video, the first video in Lab 6, and modify this filter so that you can extract all vertical lines of image. So this filter extract horizontal lines. Based on the points in this video, you should modify this filter to extract vertical lines. So this is your first exercise in today's lab. So please first connect to the Jupyter notebooks and then watch this video, and based on the explanation in this video, extract all vertical lines from this input image. Okay. In the second part of this lab, we want to use a pre-trained network named ResNet50 to recognize the race or breeds of dogs. In this part, we will use a subset of the ImageNet dataset. In this dataset, we have around 90 images of different breeds of dogs. Please note that in ImageNet in the ImageNet large-scale visual recognition challenge or ILSVR dataset, images are categorized into 1,000 different classes. So if we give an image from this data set to this ResNet network, the image can be in one of the 1,000 different classes. But in this example, we only consider dog images. Dog images are available in this folder, as we can see here. Now we want to use this pre-trained network to recognize the breed of dogs. So first, we load 3 dog images. We want to use these 3 images as test data to the pre-trained model named ResNet. So first, as you can see here, I upload these 3 dog images. So I have selected this dog, and this dog. Now, using this pre-trained network ResNet50, I'm going to recognize the breed of these dogs. Before giving this data to this model, I should create tensors. As I explained in the lecture, we should create tensors using NumPy library. Here we have a function in Python named read and prep images. This function do some preparation on the input images and create a tensor containing all the loaded image data. So this function create a tensor including the data for these three images. As we can see here, this function use NumPy package. Why? Because we should create tensors using NumPy package. So first, after some imports, we define this function here. There are all some warnings. Please ignore these warnings. They are warnings, so we don't care about them. Now I want to load model. The model is available. We should load the weight matrices for the model. That's it. So as you can see here, I load the model using this command, and I use weights option to load the weight matrices for this model. After loading the model, I call this preparation function to create tensor. So here we have a tensor named test data. Test data is a tensor including the data of these three images. And after that, I call this command to obtain the breadth of these three images. So in fact, using this predict command, I use this model to predict the rates of these three input test data. So let's start, let's run this script. Oh, sorry. Yes, and now run. Okay, as you can see here, this script doesn't have any any visual output, because you know we have here spread, and this spread contains the predicted values. As I explained here, ResNet network return 1,000 classes. So in fact, in the last layer of this model, we have 1,000 neurons. So the output of this network is a vector including 1,000 elements. In each element, we have a probability value. And this value represents the chance of the probability that the image belongs to that class. So I don't know, class 1 is classification for a specific, I don't know, for instance, breed of dog. So the value in the first cell means that the probability the input image of dog belong to that classification. So anyway, you know, we don't need all the probability values in 1,000 cells. We need to extract the top 3 probabilities. I explain the output by example. So here I want to display the top 3 probabilities for each input image. if I run this script here, for instance, for this image, as we can see, we have three probabilities here. We have three classes and three probability values. As we can see here, this dog with a chance of 95% belongs to this race or breed. Or this dog belongs to a dingo breed by a chance of 99%. So as you can see here in the output, I have extracted top three probabilities for each class, and then based on these probabilities, I can obtain the breed of each dog, as you can see here. Okay, in transfer learning section, we want to customize the classification of this network. As I explained earlier, ResNet classify the input into 1,000 classes. But now we want to classify images into two classes, urban or rural. So to do this task, as explained in this video, we use ResNet model in the first layer of the new network we are going to develop. But you know, not all layers in ResNet. We only use the first, I think, 9 layers of this model, and we remove the last layer of this model. Then, as it is explained in this video, we add one new prediction layer, including 2 neurons, as we can see here. And then we use this new network to classify input images into 2 different classes, urban or rural. So the model we are going to develop consists of 2 parts. The first part uses ResNet network. And the next part is a dense layer including 2 neurons. I know that there are lots of details in these scripts. I don't know, for instance, this softmax activation function. For classification purposes, we use softmax activation function. We will detail this activation function and these scripts in the next week. But now, please just run these scripts to see how we can modify a pre-trained network as explained in this video. So anyway, first we create a model including 2 parts. The first part is using ResNet, and the next layer is a dense softmax layer. We compile the model to, as we can see here, and then we create train and validation data. We have an input data set in this path, as you can see here. The images in this data set are labeled based on two classes, rural and urban. So we create a data set from these input images to train the model and then validate it. Here we fit the model, or we train the model. So I know that there are lots of things here. I don't know, like epoch and such kind of things. So just, please run this script, and that's it. Next week, we will go through these details. And here we can evaluate the model using test data. Finally, in the last section, we try to enhance the accuracy of model. Here we created a model, we trained it, but in this section we want to enhance its accuracy. So in this data set, we have a limited number of images. One way to increase the number of the size of input data set is to use this data augmentation technique. In this technique, we flip the images, we shift the images, and this way we create new images based on the image we have already. So in this video, you can find how we can increase the size of input data set by some operations like flip, shift, and such kind of thing. Then we will train the model using the augmented data set. You will see that because with this augmentation technique, we have increased the size of data set. The accuracy of this new model will be higher than the model we have created here. Why? Because using this technique, we have increased the size of input data. So please first fit this model, and it will show you the accuracy of the model. Then use this augmentation technique, use this image data generator function to shift and flip the images. As you can see here, flip image, shift image, and shift vertically and shift horizontally. Then you can create a larger trained data set. And you will see that here, the accuracy of your model will be higher. Why? Because using this augmentation technique, you have increased the size of your model, the size of the input data set. Okay, so in the last part, you customize RESTnet network, and you try to increase its accuracy using this augmentation technique. And please compare the accuracy of first model with the accuracy of the second model.